Okay, take a new part. Now the next module that we are going to do is weldments. Okay, SolidWorks weldment. So this is very important to make the stairs kind of structure. Okay, the industrial stairs. I will just put the photo at the end of this module that which kind of parts can be made in the weldments. Okay, so I'll just take front plane sketch. I'll make this to mm's. Again go front plane sketch line. Okay, now go to weldment. First exit the sketch. The structural membrane. This one, this one, this one. Okay, so see. Now if I had to make this part in the part design, it could have taken a lot more time. But because of the weldment model, I made it just in 1 minute. Okay, I can also edit the sketch. So we'll just increase the height a little and increase the length a little. Okay, exit. So I made this. I will just mirror. For mirroring, we'll have to go to features, mirror. We'll select bodies to mirror. These are the bodies. We have not selected the plane, so first we'll have to create plane. We take front plane, then we'll get a reference plane for that. Onto the offset side. Okay, this much is enough. So along this plane, we'll have to mirror the bodies, which are these bodies. Okay. So I just mirror them. Then hide. Now I have to create pattern in between. So what I will do is I'll take a top plane sketch, go to line. Okay. So I created this. Now I'll again go to weldment, structural membrane, select that time and see. I want this to be horizontal. So I will go to alignment. Along this, I will switch. I want this to switch inside of this. So what I will do again is I will go to locate profile, select this point. So it is taken inside. Okay. So see this kind of structure. Now I will also show you the linear pattern. So I will just go to patterns. So see, this is linear pattern. Okay. Now I'll select bodies. This body I want to pattern. But along which, okay, so you can select the, so it first asks for the direction. So select this direction and then the, okay, bodies, stick bodies. And I'll just reduce the number. Okay. So correct. So see, so this structure we have made in the weld max. I can increase this to real view graphics. I can off the real view graphics also for better visualization. Okay. So this we have made, and this could have taken a lot more time if we could have made it in the part design. But because of weldments, we can make it quite fast. Okay. I will also save this. Okay, so the next module is SolidWorks piping or SolidWorks routing. For that, we'll have to open assembly. Now come here, the piping section, go to design library. From here, you will have to choose, for example, so from design library, you will have to choose routing, then piping, and then from here, first I will take flanges. Okay, so I will take a flange. Yes, you'll have to save the assembly. Okay, and then with OK from here. Okay, so I'll just increase the length. Now we'll take a line. Now we are into 3D drawing mode. Okay, so see, so much axis we have. So first this, okay, and this, okay. Now take a line over this point. I'll snap the line over. So see, we have snapped the entire line. Okay. Now I will again go to the design library, take the T's. Okay. So zoom over here, add a T over here. This tab to increase the to change the direction. Okay. And okay. So see, now we have added the extension over here. Also one over here. Okay. Correct. And one over here also, but in the opposite direction. Okay, so now again I will have to add flanges because at the end of every pipe there is a flange. So take a flange here, add okay, here again, and here. Okay. And the next thing that we can add is, okay, so we'll add valve. I will take this valve bit well, add over here. Okay. And another location where I can add is here. I've added it. Okay. Again exit. Okay, so it's fine now. Okay. Go to the isometric view. So this kind of pipe structures also you can make in SolidWorks. And even if this we have to make in the part design, it could have taken a hell lot of time. But you can make it over here. at very fast rate. Okay, so just exit and see, this is our part, okay, of the real graphics, and you can just hide the routes from here. Okay, just hide the entire document. Yes, so see, so this is SolidWorks piping or SolidWorks routing. Now we move on to the next module. So okay, so you have to on the drafting from here, drawing. Now you have to choose the paper. So I will choose here A3 landscape. Okay, from here you can say, okay, so now it will show all of them. Okay, so this I choose. Okay, so this is the drawing window. So I'll go from here view palette. I will browse my part. So which part I want? D, inverse, 3 drawings, triple A. So I will take, okay, so we'll take the mold. So this mold dimension I want. Okay, so I will take this view. Escape, delete. Again go to view palette. Okay, so this is the front view. So this view, this is the side view. This view. Okay, so that's enough. Now I can select it from here. I can make it colorful, or I can make it with hidden lines. Okay, so see here comes the hidden line about how it will look. Okay, now the next thing that I can do is I can give dimensions. So I will choose this. I'll go to drawing and sorry, annotations, smart dimensions, and choose here auto dimensions. Okay, so see, these are the auto dimensions, and they're given to this part. Now, if I don't want this much of dimensions, what else I can do is I can select manual dimensions and I can do it from here. Okay, so this part, this dimensions. Okay, so because we made a parting line, so I cannot select this dimension directly from here. Okay, because while selecting first we made a parting line, na? That's why I'm able to select this. Okay, so now again, so I will save. Okay, so we are done with the drawings now. I will again take a last drawing. We'll also show you how to convert it into PDF format. Okay, so we'll take part 3. Open this one, this one, this one. Only 3 views are enough. Okay, this I will make in high quality. Okay, so there are no hidden lines. Go to dimension. This will be the distance from here to here. Okay, the distance between both of these. Okay, so now the thing is that the dimensions are looking very small. So I can edit the font from here. Go here, font, choose your points, choose 26. Okay, so the dimensions are good. Also the part are looking very small. So I can go from here. I can use the custom scale. It is 1:2. I make 1:1. Okay, so the parts are not here. I think 1:2, 1.5. You know, look at I make 1:1. So I move the sound. I move both of these also over here. I can choose all the dimensions. Okay. So now because the dimensions were in meter, now they were very small. So because I removed the decimal points, so they are showing everything at 0. So then I will increase the decimal point. Okay. So now they are showing the dimensions. Okay. So now I will save this. And while saving, you can save as in PDF format. You can come the PDF format. The drawings. So see, this is the PDF format. Okay. So this you can send to the manufacturer with these dimensions, then he will manufacture the part. Okay, he will do the fabrication. So these engineering drawings are also very important, and this also you can do it SolidWorks. So this is also one of the module. Very important module. Okay, so far we have been done with 7 to 8 modules of SolidWorks. So you should have understand that how vast this software is. So our next module is render tools. Okay, so I will open one of my projects. Go on open, view, drawing, Sterling engine, S23 open. Okay, so this is a Sterling engine that I made. It took me over 3 hours to make this. Okay. Now for render tools, what you'll have to do is you'll have to go into SolidWorks add-ins, and from here you'll have to on the render tools. The next thing that you'll have to do is go into add-ins from here, and here you will have to add PhotoView 360. Okay, so this PhotoView 360 has been added. Then here you will have to find render, yes, render tools. Okay, now from here, first thing that you'll have to options. You'll have to go into options. Here you'll have to adjust the resolution, the type of image format, the quality of the render. Okay, so the more quality you're going to take, the more time the rendering will take, but crisp and good results will occur. So after making this okay, then you will go into the render region. Okay, so from here you will select how much region you need to render. The next thing that you will do is go for the final render. Here you will add a camera. Okay, so this is the camera. All right, you will adjust the camera a little bit. You will make okay from here, and then you will do the final render. Okay, so the next module which we are going to perform is a very important module, which is the sheet metal, which has immense demand in the industry. Okay, so we'll take a new part. Then I will take, okay, so I'll take top plane, stage. First of all, I will change this to millimeter. Okay, then we'll take top plane, sketch, go to a center rectangle. Here, this much. Then go to sheet metal, this range. Okay, this much. Now I'll take this option. Okay. Okay, so I can do all of these kind of tricks. I will take this. Okay. Now I'll just do, this is, the length is too much, so I will just edit it. So from here I will edit the length. I will take this much length, exit, it will automatically regenerate. Now I will take edge flange. From here I will take, I can edit this edge flange. First of all, I will change the radius. Let's take the radius here from 2. Okay. So the radius has been updated automatically. If I take 5, see, it is updated automatically. After taking the radius, I want to edit this flange. So what I will do is I will go to edit flange. So this is the sketch is valid. I will delete this line, delete this line, take line from here, take to here. Okay. Next line from here to here. Okay, then go to trim entities in both of these parts. Okay. Now I'll just make a circle. Now the middle point and this one, make vertical. And this circle tangent with this line also tangent, and with this line also tangent. Then I will go to edit this part, and this part. Okay. Now this point I will have to make vertical with this point. Okay. So I will just finish it. It will automatically regenerate. Now if I want to make a cutout in between, so I make a circle. Now here in the sheet metal also I think you have extruded cut. Okay, here. So I can extrude cut it over here. Now in real life, if this part is made up of a sheet metal, then it is having bare minimum thickness. So I will have to provide a gasket over here. Okay, that's it. So in order to provide strength, so that option is here. Select both base and seam. Okay. Now, okay, so that's okay. So this is a sheet metal. That's it. Now I can increase the number. So I will just select it. Go to features, linear pattern. Around this, I will make the number 2, 3. Okay, 45. Okay. So see, these are the sheet metal. That's it. Okay. Now I will again go to sheet metal, edge flange. This side away, and edge flange. Again, the radius by default, they are not taken properly. Now, I can take this edge flange from outside, from inside. When I take it from inside, there will be a relief created. Okay. Okay. Now, suppose I want to hold over here. So for that, I will have to first flatten. So I will do unfold. I will have to unfold from here, and the bend, I will select this bend, and it will unfold. Okay. Now I can draw again here. I will go to a straight slot. Okay. So this is the slot created. Now go to features, extrude cut it. Okay. Now we'll again go to sheet metal and fold it back. So this and this is the bend. So see, it has been folded back. Okay. Okay, so what next? I can take off sheet metal. Okay, so this much is enough. So this is the sheet metal part that we have created. Now, in order to manufacture this part, first of all, we have to flatten the part. Okay, so we have flattened the part. I will take a top view and change the views to these lines. Okay, so now this part I will go and go to the manufacturer, and this extra material, the extra material will be saved because I manufactured, because I have made a proper drawing to the manufacturer, and this will reduce our cost. Okay, so here also this software is very important in sheet metal as it helps to reduce our cost and to increase the speed. And again, I will change the view to shaded with edges and take isometric. Okay, so for now the next model is the evaluate tool. So we created this element part, but we don't know the dimensions. So in order to know the dimensions, what we'll do is we're going to evaluate, then we're going to measure. So if I select this face, it will give all properties. For example, the area, the perimeter. I want to know the distance between this face and this face. Then I will select both the faces and it will give the proper distance. Okay. So this is also very important, the evaluate tool, when we want to measure the mass properties. Okay. Now the next thing is the section view that I want to explain. So if I go into section view, then this is the section view where I can see the section view of the entire assembly or entire part. Okay. This is also very important for visualizing the part. So I will take text, add on to this space, type here. Okay, so the text has been added over here. Near the page, select this. Okay, so here comes the text. Now I want to increase the font. I will go from here, take points, select, okay, so that's yeah. The next thing I will do is make it bold, everything select. Okay, I'll just go feature, explore boss. So see, the name is explore. So I'll take here, okay, this much is enough. Then I'll just hide this line, and this feature I want to make color. So I will take a red color. Okay, so I have embossed my name onto the part. So because I have my name on this part, then this is a proof that I have not downloaded this part from online. Okay, to control this. So this is also very important. Okay, so the next very important feature in SolidWorks is that we can add the daily use part. Okay, so you can go here in design library toolbox. Then in toolbox you can go ANSI metric. Now for example here for bearings. Okay, so you can call bearing. Okay, see. So you will not have to make this entire part. From here you can add and you can also edit. Okay, so this part only you can edit the features from here. Okay, no, these parts are not editable. The next thing you can add is, for example, volts. So this is see. Another thing you can add is you can go into gas. For example, power transmission gas. Let me take the helical one. Okay, so see, this is a helical gas. Because I'm adding these gears, I cannot, as a part, I cannot edit them. For example, if I take this, I'll put this into the assembly. And here, for example, if I add per gear. Now see, here I can edit. I can increase the number of feet to 45. Increase the model. Okay. And increase the face width. For example, if I take 40. Okay. So here I can edit the parts. Okay. Next thing that I can add is there are O-rings, there is a nut, so you can add nut also. Here you can edit. So they're editable only in the assembly section. Okay. Next part, there are washers, rings, O-rings, nuts, bearings. So these all things you can add. Okay. And these are all the standards. There is a Japanese standard, Korean standard, Indian standard, and this is American Engineering Society. Okay. The metric and inch for Korean standards.
Okay, so the next module, the last module is the SolidWorks CAM module. So when a 3D part is created, it has to go under a series of operations such as milling, drilling, grinding in real life, in order to obtain the required geometry. Now the path that the tool is going to follow to generate the geometry, to generate the part, that path we can simulate in SolidWorks, and that is known as SolidWorks CAM. Now SolidWorks CAM is extremely important and is very complicated. So here I'm going to just give your overview. Now the resolution of the video is little less, so bear with that. So first of all, I'm drawing this geometry which I'm going to perform the CAM. We are also going to understand the cutting path generation, CL file generation, and the G and M code generation, which we are ultimately going to input into the CNC machine, okay, which will give us the part. So I've drawn this geometry. I've drawn two holes, extrusion of different lengths to make the geometry a bit complex. Okay, I will also draw a circle over here, and I will extrude it up to a 50 height. Okay, now the SolidWorks has to be added in through the SolidWorks add-ins option. Now I'm selecting the machine. The machine I have selected is a milling machine. Okay, now the coordinate system I have given. While giving the coordinate system, one should ensure that the Z axis is always up. Now this is the stock material application, from which now there is milling operation. So I will select the topmost face and see it has generated the code. Okay, so now the last okay, so now this is toolpath generation, the path that it is going to follow, and now this is the ultimate simulation. Okay, how the milling operation will be done and how these features will be embedded on the job. So SolidWorks by itself, it recognizes for which features how the toolpath should be generated, but it is customizable, so you can customize the sequence of the operations according to your requirement. This is highly complex. The main software which is used for CAM, computer aided manufacturing, is MasterCAM software, but SolidWorks also offers a great edge in SolidWorks CAM. Okay, so you can increase and decrease the speed of this animation, and this is very helpful in presentation. So this is the actual path that the VMC machine will follow. Okay, now this is the cutting file location. The cutting file is the jobs that we are going to perform, the feature, the sequence. Okay, okay, so we have just generated the cutting file, and now this is the generation of the G and M code. Okay, it has to be saved into the tab format so that it can open into the notepad. So this is the G and M code which you can directly input into the VMC machine, and inputting the job of the stock material, you can just on the machine, and given this code, the machine will form this part.
Okay, so now we have been done with all the modules of the SolidWorks. So these are some of the projects that I have done in SolidWorks. Okay, so this is the umbrella mechanism. See this kind of mechanism. Okay, then this is the sheet bending mechanism. This is a very good animation. It is showing how the bending of the sheet. Okay, now this is the animation of a motor. So this is also very good. It took me over 1 hour to make all the parts and assemble them. Alright. Now, so this is the pen, cello gripper pen. This I made by myself without any dimension. This is free modeling. Okay, this is of no dimension, without any dimension. So I will change the transparency and I will just suppress the part. This is the part. I will just suppress it. Yes. So see, this is the pen. Okay. Don't save. Now see, this is the sheet metal part that I made. This is a hopper. Okay, hopper design. Then this is the vent, the industrial vent. Okay, for air conditioning that we use. This is also made of the sheet metal. Now this is the gear. this I made with the help of the toolbox. Okay, so see, this is the animation. This is the gear mate animation. Now this is the mold making. So this is made with the help of the mold tool. Here also I give the animation. For example, see. Oh sorry, here I did not give any animation. So I just animate it with the help of this animate collapse. Okay, see. Mold tool is also very important. So now this is the my mechanical fourth year project. This is a garbage collection mechanism. Okay, automatic garbage collection mechanism. So in the conventional way, there are people inside who collect the dustbin from you, so they have to be in the garbage all day long. So this is the mechanism which is used, which I'm making to replace them. Okay. So see, this way the dustbin will go inside and then it will come back. Now this is the bobcat. This is the biggest assembly that I've ever made. This took me over 7 to 8 hours to completely make this bobcat assembly. Okay. So I hope you learned a lot. The main aim of making whole video was to introduce you with the capabilities of the SolidWorks. So this is a very important software, and I hope that with watching this video, you would have developed interest in learning the SolidWorks. So I think that with this watching this video whole all along, you would have understood the importance of this software in mechanical engineering. You would have learned a lot and would have developed some interest in learning the software. So that was my main aim. The aim was not to teach the software. The aim was just to introduce you with the capabilities of the SolidWorks software. Okay. So thank you for watching.